Researchers describe data in terms of three kinds of measures: measures of center, measures of location, and measures of spread. So let's examine each of these measures one at a time. A note here, keep in mind that moving forward and even within this course, most of these calculations will be done on a computer. For our course, we're using R, but you may have heard of Stata, SPSS, perhaps Minitab, and we won't be doing a lot of hand calculations. However, we feel that by doing hand calculations initially with each of these measures, you'll have a more intuitive grasp of what each of these measures mean. So therefore, for this part of the class, we're going to go through step by step what the calculations would be for each of these measures. We'll start with measures of center. For measures of center, we will look at the mean, the median, the mode, and then we'll look at a couple of graphic displays that show these measures. So let's begin with the data set. The numbers below show pretest scores for 12 students on the first day of a web conference course called Statistics is Sexy 101. And you see all of the scores going across the way, starting with 72, 72, 22, 72, 66, 84, etc. So you see a listing of scores. Because the students came to the course with varying degrees of statistics background, the instructor wanted to evaluate the scores using descriptive statistics. Because when you look at this line of numbers, you get a general sense of how the students did, but it's not completely clear as to whether the instructor should be happy or unhappy or how to evaluate that data just looking at the raw numbers. So we'll begin with our first measure of center called the mean. The mean is the arithmetic average of the data values and can be calculated by hand using the following formula. Now, when we're calculating the mean, this is something that's quite familiar with most people. You simply add up the individual data values and divide by the number of data values that we have, which is the n. So in our case, in this case, if we took each of those individual data values, put it in the numerator, and divided by 12, because 12 is the number of data values that we would get 70. So 70 is the mean of our data set. The advantages of the mean are that every single value in the data set are included. And it's very widely used, and most people are quite familiar with the term. Well, you would ordinarily say average, but the mean and the average are exactly the same thing. So people always bandy about the terms average age, average weight, average income, average score, and it's quite familiar. However, there is one disadvantage to the mean. Means are very, very sensitive to extreme values. So let's say that the instructor asked the students to let her know the number of miles away their hometown is to Harvard University. So to get a sense of how geographically diverse her class is. Well, here are the results, the distances that the students provided. You'll notice that the top starts with Somerville, Arlington, Waltham. For those of you who aren't from the Boston area, these are all local towns where, not too far outside of Cambridge. And then we see some other values. We see some other cities. There's Burlington, Vermont, Hartford, Connecticut. And then we see a couple in Canada, Montreal and Toronto. And then, of course, we see one that stands out, and the one that is from Beijing, China. Now, think about the list that we were just looking at. How would you describe the impact that Beijing has on the mean number of miles? Think about what that would do if we're taking the average. it would be an enormous impact. Beijing is 6,728 miles from Harvard. That is very, very far, and by far and away exceeds the distances of any of the other cities that were reported. So let's take a look at this on a number line. You'll see in the blue box, most of the cities kind of cluster together at very, very, the left-hand side close to the 0. We have Toronto, that's a little bit further in, it's further away. And then let's take a look at Beijing. Beijing is almost off the map, it's so far away. Now, the impact that Beijing is going to have on the average or the mean is going to be huge. Let's take a look and compare the averages, the means of the two groups of numbers with and without Beijing. You'll notice that with Beijing, the average is 694 miles roundabouts. And when we remove Beijing, we have a distance of 145. So if the point of the exercise was to kind of establish, my students are taking classes from all over the world, that's true, but really one data value is inflating the mean in a huge way. If we removed Beijing, we would say 145 miles roundabouts, and that's respectable. I mean, that is certainly not the next town over, but it is certainly a much smaller number of miles than when Beijing is in the mix. So this is an extreme example, but it clearly illustrates that the mean is not always the preferred measure of center. So an alternative measure of center that could be used is called the median. So what is a median? In a set of numbers placed in chronological order, the median is the middle number, such that there are equal numbers of values above it and below it. So if we take the simple case of 5, 1, 2, 3, 4, 5, the middle value is 3, with 2 above and 2 below. Now, if we had an odd number of values, 1, 2, 3, 4, 5, 6, then we would have to take the average or the mean of the two center numbers, which in this case are 3 and 4, and the median here would be 3.5. So there is a formula to calculate the mean. The first thing that has to be done, and this is very important, that you rank the data from smallest to largest. If you don't rank the data, it's not going to work. Then we calculate what's called the location for the mean. The location is calculated by n, the number of data values, plus 1 divided by 2. That gives you an indication of where the center is relative to the whole group of data. And then we use that location to find the precise median. So let's go back to our numbers with the quizzes. We see the numbers as they were originally presented, not in chronological order, but what we do first is we range them from smallest to largest. So we see 22, 64, all the way up to 90. Now we apply the location formula, n plus 1 divided by 2. Well, here we have 12 data values. So 12 plus 1 is 13, divided by 2 equals 6.5. Now, don't make the mistake of thinking then or calling 6.5 the actual median. 6.5 is not a median. 6.5 is the location of the median. That's an easy error to make on a homework or a test, so I'm just making a big point of it right now. So that means that we would count 6.5 digits in from the bottom, or you could do that down from the top as well. And what we find is that the middle value is going to fall between 72 and 72, interestingly enough. Because we have an even number, the median is not going to be actually one of the numbers in the data set. So finding the median is simply taking the average of those two middle numbers. Well, in this case, 72 we have 72 as both of the numbers, so we have 72 plus 72 divided by 2, which equals, of course, 72. So that the median grade for the students in the class is 72. So a third measure that, of center that we have is called a mode. We'll briefly talk about the mode. Simply stated, the mode is the most commonly occurring or frequently occurring data value in the data set. Now, in this case, we'll see that we have individual numbers, but we have 72 occurs 3 different times, 72, 72, 72. So in this particular data set, we would call our mode 72. So before we go any further, let's take a look at some graphic displays of measures of center. We'll look at the histogram and stem and leaf display. Now here's a histogram. This pretty much sheds light on how the distribution is. Look to the right. That distribution we would call, just if we're looking at just that part of the distribution, symmetric, pretty impressively symmetric. Usually even symmetric distributions aren't quite that symmetric. But then look, there is a data value all the way to the left. That would make this distribution as a whole skewed left. And that is due to one of the data values, which is considerably lower than all of the rest. So a stem and leaf display is yet another way that we can show a distribution. It's similar to a histogram, but it shows the individual data values. Sometimes stem and leaf displays are called quick and dirty ways of doing calculations. You don't get as much detail, but you are using each of the data values. And you can do it in a restaurant on a napkin. It's a very easy display to set up. So how do you set it up? Well, for a stem and leaf display, there's going to be the stem column and the leaves part of the display. Now notice how this is working. If we're defining, and we're looking at the 2 at the very top, as a number that's in the ones place, then the stem 2 will be in the tens place. Therefore, we would have number 22. Now keep in mind that if we decided to define 2 in the leaves as being in the tens place, then the 2 in the stems place would be thought of in the hundreds, and we would have 220. But for this, we're considering the leaves to be in the units place. So if we were to look at the numbers, we had 22 on the top. The next number in, we have a 4 in the leaves, and we have a 6 in the stems. So we would have here 64. Likewise, we would call the number in the center, the second number in, is 66. And likewise, we would go through number by number, and you would be able to quickly identify the various numbers in the data set. Now, if you take that stem and leaf display and rotate it, take a look at what happens. We have all of the same numbers that we had in our stem and leaf, but if we rotate it to the side, look at it in comparison to the histogram. The shape is precisely the same shape. It gives us the same information, which is interesting. So in some ways, the stem and leaf display is simply a rotated histogram. Okay, this concludes our discussion of measures of center. Next, we'll discuss measures of location.